This is Logic 2, and this is Lab 7A. And there's a few different things we did, but basically it goes over a simple circuit to prove how a parity bit works. In this circuit, we're using even parity, so that basically means that if the data inputted on these data lines right here is odd, then you'll have a parity bit go high, and that'll be like a fifth bit to that data stream. If the input is as a even amount of highs, then your parity bit will be 0. And over here is a parity bit checker, and these lines up here is basically how we're going to control the errors. So we're actually inducing errors to just double check to make sure this this error bit device, this checker, the system, works correctly. And we have an output, either an N if it's normal, or if it's good, and E if it detects an error. So, real quick, our input data bus is these switches right here. And the LEDs in front of it is a little bit different than the lab instruction, so we can show everything. But these are the actual bits coming in. This LED right here corresponds to, this one right there corresponds to the parity bit generator, or the parity bit that's generated. And this LED right here is our received parity bit, which is the output of this parity bit checker. So the error inputted to this are these lines right here, and they go through a controlled inverter. So the actual output after it has potentially been induced with an error or more is right here. So if my input are all highs, I have no errors coming in, then I'll have all highs here. If I inject an error, then it actually produces the error on my most significant bit. So my input is a high, my most significant bit received, however, is a low. And then there's my error. So at any time, say if I put all zeros in, I should have all zeros out. However, if I inject a high, then I'm going to have an error code here, here, and then I'm going to have a high on that bit there. And the parity check is a 1, meaning there's an error. So if I have 2, it can't seem to detect it because it's only a single bit. Detecting an even number of errors is impossible. So it only detects odd amounts of errors. So there, it detects 3 errors, but it won't detect 4. And that's it for 7A.